Welcome all. This is Dr. Hisham Sayed. This is the second part of the lesson series on construction scheduling. In the first part, we learned about the process of developing construction time schedules, and we covered the part of how to sequence and develop logic of between construction activities. This part will cover the next step, which is how to represent the project schedule as a network. Once you represent the activities from WS, you define the durations using productivity, and then define the logic. You have information, start building the network and connect the dots. And how to do that, you have three main methods here. In other future lessons, we'll learn about more advanced, more specialized scheduling methods like line of balance. But for now, the basic scheduling techniques depend on either using bar chart or activity on node or activity on arrow. Activity on arrow was actually the first one of the first scheduling network methods applied, and it had a lot of attention to it because it was the basis for coding how schedule calculations are done. So in computer applications of scheduling, they kind of use the activity on arrow notation and way of modeling the schedule network. But it adds complications to that. So for our introductory learning about scheduling, we're covering the two other methods which are heavily used, more than activity on arrow, more used by the industry. So bar chart and activity on node. So starting with bar charts, and from its name, it's a chart made of bars, and every bar represents an activity. And the location of the bar indicates the start and finish time of the activities, and also the length of the bar indicates or represents the duration of the activity. So the activities are represented kind of with the vertical axis, and the time line is the horizontal axis. So I can see here that B takes 3 days, the first 3 days of the project, and I takes the last 2 days of the project. And I can visually easily understand the project schedule in this way. So let's see how bar charts are constructed. So we have here this simple example, activity represented with just alphabet letters. IPAs, which is immediately preceding activity. For every activity, I'm defining the logic using IPAs. So that's the outcome of the previous step. And then duration is the outcome of the second step, which is using the productivity data to figure out the duration of the activities. So for example, A and B have no predecessors. C depends on A and B. D depends on C. But I don't have to say it also depends on A and B because I'm mainly concerned about the immediately preceding activities. So kind of it's implicit. If D depends on C, it also depends on A and B. But I'm looking at the immediate preceding activities. So if I start drawing the bar chart, if you remember from last lecture when we talked about developing the logic or sequence, there are two different ways. We recommend using the reasoning backward method. But there's also reasoning forward. So either way, when you draw the bar chart, you draw it forward in a forward fashion. You start from the beginning of the project and then you go build up the bar chart this way. So you start at time 0, which is representing end of day 0, beginning of day 1. So every one of these numbers is an indication of the event of time that represent the end of the day of this number. So 2 is the end of the second day, beginning of the third day. So starting from the beginning, I look at the starting activities. Starting activities are the activities that have no predecessors, so I start with A and B. I draw their bars to scale of their durations. Then C depends on both A and B, so I cannot start C with only one of the predecessors done, so I have to wait until both of them are done. So I start at the end of the latest of them, so A and B. And then I start here C at the end of day 5, and it takes 4 days, so 5 plus 4, 9. And then D and E depends on C, so they both start at the end of C, like that. Duration of 4 and 3 for E and for D and E. 2 and 4, sorry. And then done with activities up to F, so next here is F. F depends on D, and it has 3 days duration, so it starts from 11 plus 3 is 14. And the last activity here is G, which is depending on both D and E. So the latest that finishes is E, and I start here with 5 days. So this now is the bar chart of this project, and I can see here that the project duration is 18 unit time. So the schedule here, I didn't clarify if it's daily or weekly, but the method doesn't care. You define things in using a consistent time unit. So that's 18 probably days. So the main advantage of bar chart is it's simple. It's very visual, to scale. You can see the longest bar. This is an important activity. It's the longest activity. You pay attention to it, and also you can see the paths or the different possible paths and what activities can be done at the same day. So it's simple, very visual. But the main disadvantage here is that it doesn't show the relationship. And I know that some of you already know Microsoft Project and P6 Primavera. You can actually show relationships on bar chart, but when projects get bigger, you can't track relationship that much. They start overlapping. It's hard to track the logic. So that's the main disadvantage here. So the other method we're covering is the activity on node. Is trying to overcome that. So showing very visually the relationships. So that's done by the activity on node. So activities are shown by nodes, and then arrows represent the relations between them. So activity A precedes B. So that's basically the simple network here. So let's see this same example and try to represent its network. And you see here, I'm not really focused on the duration. In bar charts, I need to know the duration so I can draw the bar to the scale of the duration. But in the activity node, it's not dependent on that. I just need the IPA. And then later, when we see the next step, which is critical path method, we will start writing numbers on the activity node. So activity node start with the starting activities, A and B, 2 nodes, and then C depends on both A and B, so I connect it with the logic to A and B. And then both D and E come out of C. And then G depends on D and E, and F depends on D. So that's basically the network here, or the schedule. But my recommendation is to start the network from a single node and finish it at a single node. So here, this is not the case. I have 2 starting activities and 2 finishing activities. So as a good practice, always start your network with a single node. So you start all the calculations from one point and wrap it up at the end at another point. So this is what we're going to do. Even if I don't have a one single node for the project, I will create one. So kind of a dummy node here I will call it start. And then I will have a dummy node at the end called end. So from the start, I can see any arrows going out of it, that's going to starting activities. And then any arrows coming into the end, it comes from finishing activities. So it wraps and summarizes the network here. I can also try to make it sure it's consistent with my understanding, starting activities, finishing activities. And also it will be useful in avoiding mistakes when you start calculating critical path method numbers on the network, which we will see next video. So we're done with this video here. We'll learn about how we represent the schedule network of an activity using bar charts and activity node. And next lesson, or next video, we'll learn about critical path method, and we'll learn about how to do the forward path and pass and the backward pass calculations to find the activity times. And then in the following video, we'll learn about activity floats or schedule floats. So thanks for watching. Take care of yourself and those around you.